are an interesting case where a small firm would be equally competitive to a big firm. The little guy has some cost efficiency that the big guy can't beat him on. But increasing returns to scale, we'll talk about, it leads to what's called a natural monopoly. In a lot of cases, the big company will keep eating the smaller and smaller companies till you end up with this one huge company who's got lower costs out there. In an industry, they get bigger so they can drive costs down. So we'll talk about this natural monopoly cost case later. So most of what we're doing here in this first case is going to be the decreasing normal returns to scale. We're going to say decreasing returns to scale with some average cost going up is going to be our first basic case. Constant returns to scale works as well because that's going to have the same properties. If you have increasing returns to scale, we're going to have to look at this in a different case because then it's efficient to have one giant firm. And one giant firm is a way that we have monopolies. And monopolies are an important place that public policy intervenes because we have regulated monopolies. So here we have East Bay Mud. So we have the water company. When they developed Berkeley, there were small little water companies competing. There was guys building dams in Tilden Park. And then over time, it became more efficient for one company to buy out all the little companies and supply one way. But now we have a citizens board that oversees it and sets the rates for water. We also have PG&E. We have the same system for electricity. And these are things that matter to this class. So we have a regulated monopoly. We have the Public Utilities Commission, a citizen board that meets and decides how much PG&E can charge us. I showed you, there's a table published of how much electricity rates are allowed to be. It's pretty complicated. But this is an important place for sort of economics and public policy that's deciding what are the fair rates for things. We have plenty of monopolies where we don't regulate them, but we have certain ones where we have set up historical reasons to regulate things. We think it's worth it to have one PG&E and one East Bay Mud Water Company, but we have a way that we regulate it to the benefit of society. So interestingly, in my lifetime, there used to be monopolies in phone service. There was one company that supplied phone service to everybody, and there was a Public Utilities Commission deciding what the rates for phone calls would be. And then along came mobile communications. Now there's multiple firms. Now there's internet telephony, and there's lots and lots of little firms. So we don't really need this anymore, potentially. There used to be a need to regulate how much and set the cost of calling between different places. And the cost of calling was way higher. Long-distance calling was like a super expensive thing. But now it's like free unlimited long-distance everywhere in America, right? So things have changed with competition when we left being monopoly. We have this for cable TV. We don't have multiple cable TV companies running cables in any neighborhood. We pick which cable company is going to service our city. We make a deal with them. And we have this one regulated monopoly that we decide on in each city. Interestingly, now satellite has come, so that's changed how we can get things. You don't own, and then now through the internet, there's other ways to get the content. But there still needs to regulate this at times. So here we can go in the last few minutes or a little bit, and we'll talk about the Swedish paper mill. And I want to see if we can do a little interactive and see if we can graph it online. So I put another Google document. That's a spreadsheet. So if anybody has their laptop, they can look at it. So there's a table in the book in chapter 9 that it starts with, and they just say, here's all the costs. So table 9.1, here's a whole bunch of costs that we got from a paper. Or you can just look along if you have the textbook for sure, and look at this table for costs. So far I've posited this is what we think average costs and marginal costs are going to look like. But in the textbook, this professor works a lot in Sweden. The way I got this job is he went on sabbatical to Sweden last semester, so I don't know what his connection to Sweden is. But there's multiple Scandinavian examples in the book, you'll notice. So we have Swedish paper mills. Paper mills pollute a lot. They pollute rivers. They release bleach and dioxin into rivers. They use tons of energy. They produce air pollution. They use tons of water. And the water comes out and gets re-emitted to the environment. So there's a whole bunch of environmental things with paper. We consume a lot of paper in our society. It is a renewable resource, but the production of it, if you've been ever driven by a paper mill, if you ever go to Oregon, you can just drive by and you can smell them for quite a while. It's like the Coalinga of Oregon, driving by the paper mill in Salem. So easy to think about different cases where we want to regulate the pollution, but first let's take this information that's like we're looking inside a firm at how much they could be producing. So here's this table, and what I want to try to do, we'll see if the computer lets me, is draw these curves together with you. Can you guys see that? Kind of. I'm sure it's super small. So importantly, let's look at, we have this table. We have the quantities. This is kilotons of paper. Who knew what the unit was, but kilotons of paper in the first column, okay? The second column is the total costs. So we could do almost all of this graphing with just these numbers because everything's going to be derived from the total cost. Average and marginal are going to be derived from that. Okay, somebody read me the fixed cost. The fixed cost doesn't change at all, right? So let's put the fixed cost in here. Can somebody read me the fixed cost on, what's the number there? Got 7, 8. All right, so the fixed cost, you guys know how to fill down. You pull this little tab in the corner and it fills everything down. All right, so there's the fixed cost. The variable costs, in this case, are going to be the total cost minus the fixed cost. So the variable costs are the total cost minus the fixed cost. We have the total cost to produce each unit of paper, and we're trying to figure out the other things. So our variable costs, we can now calculate by subtracting the total amounts minus the variable amounts. You can tell me. So the fixed variable costs are a column here. We'll do the averages later. And then the average, so first we have this graph here. So we have the fixed costs going down like this. One thing about doing things in Google Drive is sometimes, there we go. So I set this up so that this is going to graph itself. So the fixed cost of having the paper mill and the machinery there is constant. The average total cost is going up as we produce more because our variable costs are going up. And the difference between the total cost and the variable cost is going to be fixed by this amount of fixed costs. So these numbers here corresponding to the numbers in there, and this kilotons produced are the first column here. You guys know how to use Excel, right? Hope so. Hope they teach you Excel in high school now. Okay, so average total cost, we're going to do a formula, is going to equal the total cost divided by the quantity. So in Excel formula, it's B2 divided by A2. Oops. Oh. The average fixed cost is going to be our fixed cost divided by our quantity. The average variable cost, it will be our variable cost divided by our quantity. So we can take these and fill this down for all the different levels of output that they've given us. And we'll see that pretty much matches up. So we have a column in table 9.1. So I think these are pretty much matching up, our columns in table 9.1. So we are able to make these graphs. There we go. All right, so we're making these graphs that I just drew, and I just sort of said these are the graphs, right? So average total cost going down, and then it starts going up. The red one, average fixed cost, is the one that never goes up. It just goes down hyperbolically, asymptotically. So the red one is the fixed cost. That's easy. And then the variable costs are going up, and they're converging closer and closer to average total cost because the contribution of average fixed cost is getting less and less. So pretty straightforward. The last one we want to do is marginal cost. So I hope this works. So this formula, we're going to have multiple terms in it, is going to be the total cost to produce an additional unit minus the total cost to produce. So we had it as place to write it. We had total cost to produce one additional unit minus to produce the cost we're at now, divided by how many additional units. Oop, I need a bracket. Divided by A3. Let's say A3 minus A2. How's my formula looking? See if this works. See if this loads itself. All right, so there is our marginal cost curve going up of producing an additional unit. And it's going to go through the bottom of average total cost and go through the bottom of average marginal cost, somewhere around here. So these graphs aren't super sweet, but it's just nice to see that we could get them all by calculating from the total cost that we started with. Yep. Can you see it? So yeah, total cost of Q plus 1 minus total cost of Q in a bracket. So in this, it's B3 minus B2. One thing that's important about this is we need to delete this last cell because we don't have the cell plus 1. We don't have data for cell plus 1. But anyways, so here, total cost Q plus 1 minus total cost of Q. So that's B3 minus B2 divided by quantity that we're increasing. Quantity plus 1 minus quantity now. So in this formula, that's A3 minus A2. So we're differencing it out. One important thing to think about in the spreadsheet is that when we difference total cost plus 1 minus total cost of Q, all of the fixed costs are going to get netted out because the fixed costs are the same. It's actually, we could also do the formula with variable cost because variable cost is the only one that's changing, the only one that's going up. So how much did the variable cost increase divided by, this is an approximation, it's not the calculus thing, this is the discrete chunky attempt to do the slope of a curve, it's not the calculus approximation of the slope of the curve. So it's not going to be necessarily the same as the book. The book has ones and they say, the values are derived using information not presented here, if you look at table 9.2. So the marginal cost numbers are different because we're just doing a chunky spreadsheet approach here, but at the areas that matter, they match up. At the areas out at low quantities and high quantities, they're quite different. They diverge because they're using some sort of numerical approximation of marginal cost that's more precise than this chunky spreadsheet way. So this is potentially on your next homework, but hopefully you can find the spreadsheet online and look at it and look through it. So we have a paper mill. They've given us a table of their internal cost structure. We can figure out their variable costs, marginal costs. And if we know their marginal costs, we can think about where they should be producing. If we have their marginal costs and their average costs, we can think about how much profit they're making because we know where they should be producing and we know how much revenue minus cost would be. Here's the nice smooth graph of the thing that we just did. They've done marginal cost using data that we don't have, but here's their nice smooth one. Empirically, we're going to look at this. The marginal cost curve are going to go through the bottom of the average cost curves. We're going to learn that because we really need to learn this graph. It'll be on the midterm. Price equals marginal cost is going to set us to figure out how much to produce. If the price is $1,000 per ton, we're going to produce this many tons of paper, kilotons of paper. Marginal cost curve is going up. If the price was high, if we produce at any more than this point, the costs are going to be more than the income that we're making. If we produce at any less than this point, we could make more money by increasing production to 270. So we know what the person in the Swedish paper mill should be doing in terms of output. And we know where they should pick the amount of output to do, 270,000 tons. That's how much they should be producing. Then we can look into their average cost curves. And at 270, we know, so we have a table point for 270. We have their average cost there. We know how much it's costing them to produce. And we know how much profit they're making. So they're getting revenue minus the cost at that point. And we can see how much profit there is in this firm. This is important because when we want to regulate their pollution, we want to know how the cost changing with our pollution controls are going to affect their profitability. So the paper mill is polluting. There's different kinds of regulation of the pollution, and there's different ways that it puts costs. First of all, we could say you need to install something that's going to scrub the bleach out before you release it into the air. You have to put this big complicated thing on your smokestack. It's like capital. It's like a big fixed cost. We could say you need to run another additional production process that's going to clean the water before you release it back into the river. And that's going to take a whole bunch of inputs. They're going to have to use a lot more energy to do that sort of cleaning process and the pumps and the filters and stuff. So we could have an increase in variable costs, or we could have an increase in sort of a capital costs. But as we shift their cost curves up, if we shift their marginal cost curves up and average cost curves up, they're actually going to produce less. And so to the extent that we're going to model some sort of tax on the output of paper, we're going to model how much less paper the firm is going to produce. So I think I will wrap it up there and keep going with all the same stuff next time. So please take a look at Chapter 9 and come to the office hours if you want to talk about the homework set that's out there.